Hi, this is my first scratch roll, and I'll be explaining a simple sort algorithm. So first, I'm just going to run this and just show you how this code works. So I generate 10 numbers, and it will automatically sort all of these numbers. As you can see, the sorted list has all the numbers in order, while the unsorted list has all numbers in a random order. So now I'll explain how this thing works in detail. So I'll just switch sort faster. All right, so now we can see a better breakdown of this code. So if we run this, let's say just five numbers for speed, so we get all five of these numbers. So if I click space, I will see that a few terms have been added. So first, I decide to add an incredibly large number that has no chance of being added, because the largest number that can be added, like specified, is 1,000. So if I add this, then there's simply no way that we can ignore this, and allows us to remove it later. Uh, the reason why I added this will be explained later on. So as you see, this has already ran a few iterations. So we added one term here, the first item, 877. This allows us to set like a boundary to like where we should start our sort. So for example, 690 was smaller than 877, so it goes in front. However, if so now let's look at the next term, 892. As you can see, 892 is larger than 877. So this means that if we run this, this means that it will go down this term. So 690, 877, these are all smaller. And then it finds that the 10 million or so is actually much larger than 892. So it will stay under the 10 million, and then we just insert it at that location. Next, for 520, since it's the smallest number for these, it immediately finds its position, which is smaller than 600, which is the first term, as it is the smallest, and then we insert it at that position, and then it will run and end up there. So let's just run this one more time, and then we see that 567 was added in a similar manner. So now we see that this number, the very large number, was deleted as it is clearly not a part of the unsorted list. So, and we just added it for simplification's sake. So we just delete it here by finding the item number in the sorted list and then just deleting it. Finally, we also delete a blanked item that appears after we run everything. I'm not sure how exactly that is formed, but it just forms it, and it's just easy to remove by just deleting it from the sorted list. All right. Now we can go on to like how this algorithm actually is called. So this algorithm is a selection sort algorithm. This means that it's taking each term and then selecting it to be put in a specific location in its sorted list. Usually, this is all put into a single list, but I just split it up into two lists in order to just simplify things as usual. Again, uh, so so when we started with 800, 690, and 10 million, our next term was 690. Our 690 was then put down right under 877, and this went on, and then this allowed us to sort, and this repeated sorting all of the numbers. So that is all for this time.